Yeah, let's see what it's asking us. Okay, so we have a phone plan, and basically the idea is that the amount that we're going to be charged is based on how long we've been talking for. So the first minute is going to cost one rate, some number of cents. The minutes 2 to 10 will cost a different rate, and then everything after 10, so like minute 11 and beyond, are going to cost yet another rate. So basically that's what we're given in the problem, as well as this S, which we'll talk about in a sec. But basically we've got the rate, like how many cents does the first minute cost? How many cents do each of the minutes from 2 to 10 cost? And how many cents does every minute 11 and beyond cost? So I mean, these are pretty straightforward naming conventions here. Minute 1, minute 2 to 10, minute 11, maybe, like minute 11 plus or something like that. Might have been slightly more descriptive, but I think these are good. And then S. So what's S? Well, basically S is the number of cents that we start with here. So in this case, we're saying we start with 20 cents. How many minutes can we talk for? That's basically what we're looking for in the problem. So for this particular one here, we start with 20 cents. Our first minute costs us 3 cents, so we're left with 17 cents at that point. We could run through all of these minutes from 2 to 10. There are going to be 9 of them. Each of them is going to cost 1. So we've got that and more with our 17 cents. So basically we'll take 17 minus 9, we get 8. So then basically the question is, now that we've already been talking for 10 minutes, how many of these minute 11 and beyond can we afford? And we've got 8 cents. They cost 2 cents a piece. So that means we could afford 4 of those. 10 plus 4, that's where we're getting our 14 over here. So that's basically it. We've got this phone plan. We've got a number of cents, and we want to know how long can we talk for with this number of cents. Okay, so let me know if you've got any questions, comments, or concerns about the premise here. In terms of how we're going to approach the solution, well, there's a fairly straightforward solution that we can use. I mean, we're probably going to have to include some if statements and stuff like that. But there is going to be a relatively simple solution that we'll eventually end up at. But before we get into the simple solution, I want to take this opportunity to talk about some sort of like object-oriented ways we could solve this. So in particular, what I want to use here is going to be something like a linked list. So we've talked about linked lists before. I mean, basically the idea is that we've got nodes and they're joined to each other. So each node will have like a value and then a next. So this is our first node. Its value will be 3 because this represents minute 1. So it's got a value of 3. And then it's going to have a next. So it's going to be linked to the next node, which is going to have a value of 1 because this is representing minute 2. So each of these nodes represents sort of like a minute that we would talk for, and the value that they'll hold will be the rate of that minute. Okay, so we're going to have a whole bunch of these. I'm not going to put like all 9 of these ones here, but we'll say, this goes to here, and that there are 9 of them. So let me grab a different color for a sec here. Yeah, we'll say 9 times, let's say. Okay, 9 times. So after we're finished with these 9, then we go on to our minute 11 here, which will be 2. Okay, cool. Yeah. All right. So then basically at this point, the next one after that is also going to cost 2. After that, it's still going to cost 2. It's still going to cost 2. Like, it's basically everything beyond here is going to be 2. So like, the thing is, we don't really want to make our list infinitely long, and like this could go on like literally forever, right? I mean, like every single one after this is going to cost 2. So since they're all going to be 2s, I mean, yeah, we could do something like this where we have like a whole bunch of them, but the question is, well, how many of them? Like we knew in this case that we only needed 9 of them because that's it. It's just minutes 2 to 10. But this is like minute 11 to whatever. It could be like a billion. So I don't want to have to put a billion of these nodes in here. Since we already know that the value for each of them is going to be 2, we can do something kind of slick here. So basically we can say, instead of this pointing to some other node for its next, we'll say that it'll point back to itself. Okay, so we have sort of like a fish hook kind of shape here, or like a candy cane if you want to think about it in more festive terms. But basically the idea is that we've got a linked list which eventually starts to link to itself. So if you remember back in, was it just the last one we did? No, it was the one before that. It was task 6, circle of numbers. The way we looked at it this time around, which was a bit different from the way we looked at it in the intro, if you look at the core task 6, we used a strategy sort of like this, where we do a linked list that's sort of linked to itself. Except in that case, it was just like the whole thing was a circle. So it was like the last node had a next, which was the first node. So it would just loop around, like you would eventually visit all of them, sort of thing. This is a bit different because we're kind of going through this like preamble section over here, where we've got the 3 and all the 1s, or whatever those values would be depending on our variables. But the point is, after we're done this sort of preamble section, then we just get into this loop. We don't need more than one of these 2 nodes, because everything after that is just still going to be 2, still going to be 2, still going to be 2. So we just go next, 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 and it's going to be 2 every time. So that's nice. It's efficient. We don't need to worry about making this infinitely long. So it's kind of like a fusion between a traditional linked list and something more like what we had in task 6 with that circle of numbers that connected to itself. We're sort of combining the 2 ideas, I guess you could say. Okay, so let me know if you've got any questions about our game plan here. If this is at all unclear, feel free to leave a comment or put a message in the chat. As for now, we're going to try to implement this thing. So we know that it's going to be a linked list, or at least it's going to follow the principles of a linked list pretty closely. We're going to start by having we'll make a node object, right? So we'll do a constructor for node, and then we'll do a constructor for like linked list, or maybe we'll call it like fish hook or something like that. Let's call it fish hook. That'll be fun. And then basically the idea is that each of our nodes is going to have a value, like the 3, and a next, which would be like this whole node, not just its value, but the whole node. All right, there's a lot of talk. Let's get down to business. Let's actually start implementing this stuff. So first thing we want to do is make a constructor for node, function node, and it'll take in value as an argument. And basically it's just going to have a value of whatever we give it, and it's going to have a next, which initially is going to start as null. It's not going to have a next right off the bat. We're going to assign it a next, but for now it's just going to be this. Okay, and then we're going to do another constructor, which is going to be fish hook, like we said. And it's going to take 3 inputs, A, B, and C, let's just say. But basically what these are going to represent are the minute 1, minute 2 to 10, and minute 11. You remember in the fish hook, in the drawing we had a second ago, basically we had the nodes start at 3, then a bunch of 1 nodes, and then a single 2 node which linked to itself. So that's what A, B, and C are going to be, like the 3, the 1, and the 2, respectively. So we'll start with this.head is assign the value of null. So if you remember before when we did some linked lists, we used head as sort of like, just to sort of keep track of where the list is supposed to start. So in this case, it should start at minute 1 is going to be the idea. Okay, and then basically, okay, we're going to have this variable called previous node, and we're going to use this so that we can construct the linked list. And previous node is going to be used to link them together. So we're going to be kind of like working with 2 nodes at a time. So we'll have the current node, which will assign it its value, and then the previous node will have a next value of our current node. That's the idea. So whatever one we had previously, now it's linking to whichever one we're working with now. The first node that we want to work with is basically going to be a new node with a value of A. That's our minute 1 time right there, right? And also that's going to be where we're going to put our this.head for now. That's what it's going to point to. So this.head is going to be assigned the value of previous node. Okay, so, and I mean, I realize that's maybe kind of a misleading syntax here. Like maybe I should have said first node, let first node be assigned the value of new node at A. This dot head is assigned the value of first node. Yeah, that probably would have been a bit easier to deal with, but there's a reason why I went with previous node, and I'll show you what that reason is. It's basically this. So we're gonna do a loop now. This is filling in all of the minute 2 to 10 nodes. So like in the example we were looking at before, all those ones. You remember we had 9 of them linked together? So that's what we're doing here. We're starting I at 1. It's going to be less than 10. So these would be like the indices of the values we're going to be filling in here. So let node be assigned the value of new node with a value of B. We're going to say previous node dot next is going to be assigned the value of node. So again, in the first time this runs, previous node is this node with a value of A. We're going to, and keep in mind when we first declare the node, when we first instantiate the node, it's going to have a next, which is null. You know, it doesn't really have a next to begin with. Okay, so then basically at this point, we say, now we've got this new node. It's actually, hey, let's make this visual. We might as well. Okay, so basically we're starting out here. We've got a node and it's going to have a value of A within it. Okay, and then it has a next of null, so there's no next. I'm not going to put an arrow in. And then we're going to make, so that's previous node. And then we're going to make node, first iteration of our loop, node is going to be this thing right here. It's going to have a value of B within it. And then we're going to say previous node dot next, it's node. So this is previous node dot next, now it's node. Cool. All right, so that's good. And then the next time this loop runs, it's going to make another node. It's going to have a value of B. Again, the next is null on this one. And then it's going to run this, previous node dot next is node. Now currently previous node is still this one over here, so it would actually be doing something like this, but that's not what we want. That would be wrong. So instead of that, what we actually want is for this one to be linking up. So at some point we need to change this. We need to say previous node is going to be this one. So that's what we'll do after this. Previous node.next is node, and then previous node is going to get assigned the value of node. Okay, so the next time this loop runs, it's going to remember the node that we were working with last time, and then it's going to make a new node that the previous one is going to link to. So that's what this is all about. Okay, cool. Again, let me know if you have any questions on this stuff. All right, so basically we're at the point now where we have the first 10 nodes all loaded up into our fishhook here, our linked list. So we have all the nodes, well, the one node that would have the A value, in this case 3. We've got the 9 nodes that would have the B value, in this case 1. Now we need that final node that's going to have the C value, in this case 2. So we're going to say let last node be assigned the value of new node with a value of C. And then we'll say previous node dot next, it's going to be last node. Whoops, last node. So that's kind of like just this stuff we were doing over here. Previous node dot next is node. Same thing. Previous node dot next is last node. So this is, at this point, the previous node would be just the final minute 210 node. So the last node that we put in that had a value B, it's going to be the 10th node in the list. And then its next is going to be, yeah, this last node, the one with the final number of, the final minute rate. So like any minute from 11 beyond, it's going to be this one. It's going to be the rate of what we're calling C here. Okay, so all of this is pretty straightforward, pretty standard stuff. What's going to really set this apart is the next line that we're going to do. So this is really, at this point, we're talking about a linked list. There's nothing unusual about it. Now, when we do this, last node dot next is assigned the value of last node. Now it's something else. Now it's something unique. Now it's our fishhook, because now our final node here doesn't link to something else. It links to itself. So we're just going to keep repeating for something like that. Okay, so we've got a lot of structure here. Let's actually start to investigate this, I guess. The only problem is that we don't really have anything that's going to communicate back to the user. So let's make a new function. We'll call it this.get. Okay, so it's going to be a function that takes in an index. And basically the way it'll work is we'll just loop through. So we'll say let node be assigned the value of this.head. And then we'll just say, I guess, like while minus I. Should we do it that way? And we basically want to run a loop here. Yeah, while minus minus I, we basically just want to say node is node is assigned the value of node dot next. Let's do that. And then at the end, we'll just say return node dot value. So we're just getting the value of something within the list here. That's basically it. Hopefully I didn't make any mistakes here. I guess we'll find out. So we'll say let hook be assigned the value of new fish hook. Okay, so we're instantiating this now, and we're going to give it some arguments. We'll give it min1, min2 to 10, and min11. There we go. So we're making our new fish hook there, and then we want to do, let's say, return hook dot get. Let's just get the element with index 5. So we should expect that to be a min2 10 one. Great, so we're getting 1 from that. Over here we're getting 2. Awesome. Over here we're getting 1 again. It's basically just whatever the rate is. Yeah, okay, so they're all 2 and 1. But anyway, let's say we want to get the 0th element. What's that one going to be? Or is it going to give us something? Oh, no, it's not. Okay, so while minus minus I. Oh, I get it. Yeah, okay. So basically the issue here is if we're giving it 0, then it's already done, you know? So there are a few ways we could deal with that. Maybe we'll just do something like this. We'll say for let j be assigned the value of 0 if j is less than I, j plus plus node is assigned the value of node dot next. Let's try it that way. Just making a new variable there. Yeah, okay, so that's giving us the 0th one. Basically the difference here is since I'm saying j is less than I, j starts at 0. If I is already 0, it's not even going to enter this loop. So that works a little better. Okay, cool. I mean, this is all like, we're probably going to get rid of this dot get, so I'm not too concerned about this stuff in here, but well. Okay, so that's giving us 2, that's giving us 10. This looks good. It looks like it's giving us our 0th element. Let's make it a 1 and we'll see if that works the way we expect. Right, so it's giving us a min2 10. It's giving us a min2 10. This is looking good. And then what if we made it, let's say 9? What would we expect from that one? Yeah, a min2 10 value. If we get to 10, I'm maybe expecting the minute 11 value. Yeah, exactly. You might be thinking, well, why would you expect a minute 11 value if you're putting in 10 and not 11? Well, it's because these minutes are 1 based, whereas my indices over here are 0 based. So like the element with index 10 is technically the 11th element. So yeah, that's the reason. Anyway, this looks good. It looks like it's working. Now, one thing I was just thinking about is I'm looking at this stuff, and some of these we're not really reassigning, you know, like node over here just stays node. So I think I could make that a constant. I think I could make this one a constant as well. I'm just trying to be on the lookout for those kinds of things. Yeah, okay, so that's still working. Great. But this isn't exactly what we're trying to do in this problem, right? Oh, even this could be a constant, I'm pretty sure. We're not exactly trying to just get the ith element or something like that. We're trying to tell, well, how long could we make this go on for, you know? Like if we have s cents in this case, how many minutes could that buy us? Okay, so we've got our this dot get over here. Let's get another one. We'll say this dot, I don't know if this is the right word to use. I'm going to say appraise. I kind of feel like that's not totally the word I'm looking for. Because, okay, normally appraise would mean like, how much is this worth, right? Whereas we're almost kind of trying to do the opposite here. We're saying like, we have the value, we know how much money we have. We want to know what could this buy us? You know, what could we get for this? So yeah, I don't know if that's also considered an appraisal, but it's what we're calling it for now. So, okay, basically we want to do something, I was going to say kind of similar to the dot get. It's not exactly similar. We're going to start with this dot head. So we're going to have a node that we're sort of following through here. And basically we're going to say, we'll do a for loop and we'll say let how many be assigned the value of 0. This is basically how many minutes we're going to be able to chat for. We're going to not have anything in the middle for now, and we'll just do a how many plus plus. And you might be looking at that and thinking, are you sure that's okay? That looks like an infinite loop to me. It also looks like you're using a block scoping with the let here, so how could you even access how many outside of this loop? So yeah, it looks a little questionable, I guess. But trust me, check it out. So we'll say if value is less than node.value. In that case, if the value has fallen off to the point where we can't afford the next one, if we can't afford the next minute, then we'll just say, oh, okay, well, looks like we found the value here, return how many. We can't afford the next one, so whatever value we've gotten up to at this point, that's the answer here. Okay, and if that doesn't get triggered, then we'll just move on to the next line. We don't need to worry about the return there. And then value is going to be subtracted node.value. We're going to have that much less because we've already spent it on that minute. We're saying, hey, is value less than node.value? Oh, no, it's not. Okay, so value must be greater than or equal to node.value, so we can take away node.value. We can spend that amount, basically, that number of cents. And then we'll move on to the next one. Node is node.next. So that's basically it. Okay, so let's test this function. We'll try it out. So appraise. We'll just say we've got 5 cents for now. How long can we talk for? In this case, 3 minutes. You spend the first 3 cents on the first minute, and then a cent each on the second and third minute. So yeah, 3 minutes. That checks out. If we were to look at the next one, just 2 minutes, because we'd spend 2 cents on the first minute, 2 cents on the next minute. We won't be able to afford the next minute after that, so just 2. Okay, it seems to me like that's working good. So really what we want is appraise at S. And looks like that's what we're looking for. I mean, it's passing all the tests here, so that's great. I'm just wondering if there are any other changes we need to make before we submit this. Let's get a semicolon in there just to be proper about it. And you know what? I'm just going to delete get. We don't need it anymore. We're just using appraise. That's it. So we might as well make our code a little more lean if we can. Okay, cool. So that's passing all the visible tests. In case anyone has any questions about this, I mean, I just want to reassure you because, yeah, I realize it might seem strange that this loop doesn't have an ending. We could even put like true in here just to really emphasize the fact that it's an infinite loop. It should go on forever. So if you're wondering, well, why isn't it going on forever? It's because of the return here. As soon as we see return, that corresponds to this function, the appraise function here. So as soon as we return how many, the function's not going to go any further. It's not going to look at the next line or anything else in this, so it's definitely not going to do another iteration of this loop. It's going to end the function. So return is one way to do that. Break would be another way to do it, but I'm just returning from within the loop here because how many, since I used a let, how many is bound to the scope of this for loop. If I was to try to do something like, oh, return how many out here, it would be like, what are you talking about? Reference error. I don't know what that is. So unless we were to use a var or declare how many outside of the loop, yeah, we wouldn't have access to it outside of the loop. So that's how that's all working. Let's just run that again, make sure it's still good. And let's see if it passes the hidden test. We might as well. Oh. And yeah, it does. Okay, so we got it like that. The intro gates is 100% complete. That's nice. Oh, nice little bonus for that. Okay, great stuff. So, okay. Oh, thank you. But yeah, not right now. Okay, so basically this is one way of doing it. This is one way that we can pass the test, one way we can solve the problem. It's overkill, that's for sure. I mean, this is definitely way more work than we need to be doing for this relatively straightforward problem. Okay, so we don't need to do it this way. It's just kind of a fun example, and it gives us some exposure to some of these object-oriented programming concepts. So we'll say that's phoneCall 1, and I'm just going to paste this back in here, and I'm going to try all of this. Okay, there we go. So back to square one here. Let me know if you have any questions about this one below. Again, I'm not claiming this is an efficient way of doing it. It's just, it's meant to be an educational example more than anything. Kind of a neat data structure that we're using, but yeah, it's not really what I would recommend in production. So as always, we want to be using sort of like a math formula if we can, to just get there directly. So here's what we're going to do. We'll say let minutes, be assigned the value of 0. We're going to start with that. And ultimately, that's the thing that we're going to be returning. Okay, so what are we going to do? Well, we'll say if s is greater than or equal to minute 1, then mins is going to be assigned the value of wait a sec, mins is going to be, well, I guess we can just say 1 at that point, right? Because we know we can at least talk for 1 minute. And then we'll say if s is greater than or equal to minute 1 plus 9 times minute 2 to 10. So in other words, if the number of cents we have exceeds or is at least equal to the cost of the first 10 minutes, well, then we can talk for 10 minutes at least, right? So we'll figure out what to do there. Otherwise, we can't talk for that amount of time. So we're going to have to figure something else out. So in this case, this is basically telling us, okay, yeah, we have enough money for the first minute, but we don't have enough money for the first 10 minutes. So we'll try to figure out the value that's in between. It's going to be math.floor of something, right? Because we know we're not going to be able to talk for like a minute and a half. It specifically states that in the problem too, rounded down to the nearest integer. So definitely a floor is a proper thing to do here. So what are we going to be doing? Well, we'll do a division. We'll say s minus the first minute plus minute 2 to 10. Mins 2 to 10. Okay, minute 2 to 10. Okay, cool. And then we're going to divide that by min 2, 10. Okay, so what are we doing here? Basically, the idea is that we're trying to say we're subtracting minute 1 from s here. Okay, yeah. We're subtracting minute 1 from s. That's sort of the idea. And we're doing this, actually, okay, I don't super like it that way. Let's actually do this differently. Let's put the plus 1 totally outside here. Okay, this is the idea. We've spent minute 1, however many cents that was. In the example, it's 3. So let's say we've spent 3 cents. So we don't have 20 anymore, we'd have 17. And we'd say, okay, so we were able to talk for that first minute. We spent the 3 cents. We were able to talk for that minute. So that's why I'm putting the plus 1 out here. That was the same as like the plus minute 210 I had in here before. It would just divide out to be a 1. But anyway, less complicated this way, I would say. And then we're dividing this by minute 210 because we're saying, okay, so 17 is what we have left over. How many times does that 17, how many times can it be divided by the 1? And bad example, because we wouldn't actually end up in this part of the logic here with this example. Maybe if we started with like 8 cents, let's say, so we start with 8 cents. We want to know how many minutes can we talk for? So we'll do 8 minus 3, that's 5. We can talk for 5 more minutes after that. So it'd be a total of 6 minutes. So that's basically what we'd get from this case. Now, in this case over here, we'll say that minutes is going to be equal to math.floor of, okay, so what are we going to have for this one? Basically, s minus the cost of 10 minutes. What was the cost of 10 minutes? Well, it was this right up here. So minus min 1 minus 9 times min 210. Okay, so that's the cost of 10 minutes. And we're going to take that value, we're going to divide that by minute 11. Because that's sort of like, this is the leftover money after we spend on the first 10 minutes. However much is left over, find out how many times minute 11 fits into that. And then add to that 10, because we know we were able to talk for 10 minutes before that, right? That's what we spent this amount of money on. Okay, so is this looking good? Do I have the right number of parentheses here? I think it's looking good. So let's see if that runs. Will that give us the answers? Yeah, it's giving us all the right answers here. So that's not bad. But it can be better, I think. Yeah. Because, I mean, check it out. We've got s, we're first asking, is it greater than min 1? And then we're asking, is it greater than min 1 plus all this stuff? And basically, this has an else to it, right? So either this will be true or it'll be false. If it's true, we're going to reassign mins. We're not doing a plus equals here, we're reassigning it. If it's false, we're going to reassign mins. Again, we're not doing a plus equals. So basically, it kind of means that this part over here is sort of useless in a sense, because like it's never going to make a difference. Like we're always going to be reassigning whatever value it gave us. So we don't actually need that part there. In fact, we could do something like this. Let's say constant 10 min cost. Okay, so 10 min cost is going to be this stuff over here. Let's just control X that, put it in there, and then basically 10 min cost. Okay, and that's what this was. So S minus 10 min cost. There we go. So is that still going to work? Yeah, not bad. Okay, cool. Next thing you might be noticing is we're basically just returning minutes one way or another. So we're just returning this, or we're returning this. So we could just say like return this. So we're going to do a ternary here. Return if this is true, then we'll return this part over here, right? And if it's untrue, then we'll return this part over here. At the end of the line, but yeah, there we go. And let's see if that works. It does. And it also means we don't need this minutes thing anymore. So we basically just have our 10-minute cost, and then we're just returning this thing over here. But check it out. Math.floor is something we're doing one way or another. So we could sort of put all of this inside the math.floor. And it's going to be a little weird, but I think it should still work. So, oh, mouse is getting a little choppy. Let's try that again. Okay, so math.floor, and then inside that, we'll say, is this true? And, okay, it's either this or it's, let's just bust open the math.floor part there, and, whoops, I need that, okay. And then we'll close that up. Oh, is that the wrong number of these? Yeah, okay, so let's try that. Hopefully I didn't mess that up. Oh, I did, okay. Let's see, is that good now? Yeah, it's good. Okay, cool. So that's a lot simpler, isn't it? Great, yeah, and it's correct. Okay, now there is one little bit of an oversight here. There's one case where this one might actually fail. So in that sense, the bottom one would be a better algorithm, but we could just put in sort of an if for that. What's the one case? I'm gonna leave it as an exercise. Yeah, we're gonna finish up with this one for now. So nice job, everyone. That's it for this one. So